Let's take a small break with computer program and make this similar remote controller on STM32. I found in my storage old board STM32F407 with TFT LCD and decided to build this device. Well, I was planning to spend only one video for this device, but it seems a little bit a large project, and we will spend 3 videos for this device, because it's have a lot of different functions in STM. But in any case, we will study how to use UART port, we use DMA, and some other different use graphic user interface. So we will find how to build STM32 projects. It's what we need. We need board, LCD, connector for remote, we need rotary encoders and wires. Let me show you what we are doing. So I already did this project, but let's go step by step. The first, we need to go to connectivity. And select crystal, ceramic and high-speed clock. In the system, we need to select serial wire for JTAG. Next, we need timers. We are going to use 4 timers for rotary encoders and 2 timers for sending commands and for button. So timer 2, 3, 4, 5 we need to set to encoder mode. Encoder mode, and don't forget to put global interrupt on the bottom in NVIC interrupt table. Timer 6 we need for the button. Prescaler, let's put 8399 and counter 100. 8399 is because the CPU speed is 84 megahertz. So we need to divide it for to set the timer period. In our case, it will be 100 milliseconds for sending commands and 10 milliseconds for the button. Here we need to set FSMC, and connectivity is for LCD, nor flash. Select NE1 chip, select LCD interface, LCD register, select A18, data 16 bits. And here on the bottom, address set 1, data setup 5, and bus turn around 0. SPI we need for the touch screen. Select full duplex master. And also we need USART port for send and receive data. We select single wire. NVIC global interrupt is selected. And also we need to make DMA for receiving. So we need to press add and select USRT RX. DMA2 stream, mode circular. All other left like default. With connectivity we finished. Now we need to select CRC. It's required to use graphic user interface. Let's see our pins. So GPIO output is for the LED, input for the button. We're going to use 2 buttons now. One more for button. GPIO out. I not remember for what is it now. T-pen is for touch screen. PB1 GPIO output, it's LCD backlight. All other pins we already see the program set it for FSMC. And for SPI for touch screen. USART port is PA9. Let's check GPIO for the buttons. Let's make it pull up. So all inputs we will do pull up, because I'm not using external voltage on the rotary encoder with the button. T-pen is set as GPIO XT5. So let's generate the code, and now let me show you what is it here. There is not only main file, I already added here a lot of different files. ILI9341C is LCD driver. Font C, font A 2420 1612, it's different fonts to display letters and digits. XPT 2046, it's for touchscreen driver. Button C is button driver. And in INC folder is the same button driver, LCD driver, colors, fonts. Now we need to add graphic user interface into our program. I decided to add STM32F407+LCD. It's very simple graphic user interface, and it's available in the STCube in STCube program. It's located in drive C. Drive C, user styles, STM32Cube repository, STMCubeFW, it's downloaded library for our board, middleware, STM32F407+LCD. Here is library and software to create graphic interface. We need to copy wall INC folder into our project. I decided to put it here into the drivers. Created folder emwin. Here we copy wall INC folder with all H files. Into the src files we need to copy GUI-X, GUI-conf and LCD-conf files. And also we need to copy library for our CPU, it's WC32A. So we copy C files, necessary C files. It's a software which available for to create the graphics. So GUI builder, here we're going to build our interface. So when we create new file or open existing one, called Windows DLG C. When you create the file, it will be saved in Windows DLG C. It's our file with visual components. We can add new, delete unused ones, or change any property. So I decided to build it like this: large digits for VFO and read. As meter, I copy as meter image from Icom 7300 and 5 buttons of the mode. Because it's not commercial program, it's just a small project just for fun. When we create this file, we need to copy it into the drivers mbin src. The file should be here. And don't forget to copy library STM cm4 wc32a. This library is for STM32F407. And after that we add in headers GUI H and dialog H for graphics, and window DLG H is our user interface image. Let's see, button, LCD, touch screen, graphic, fonts, colors. So this lines generated by the program automatically. And main, it's generated by the program. So here we need to, in user code begin to, we need to initialize the button. We need to initialize the timer which working with the button. We need to initialize LCD, and we need to switch LCD backlight on and set orientation to horizontal. Set LCD orientation 1. Then we run welcome function. Welcome function is just display on the yellow background, just radio not connected. Press any key to connect. That's it. It's not doing anything else. And then we run the function while connect not equal 1. So we're waiting for radio to connect. Then we press the button. When we press the button, we fill LCD by white color. Change set cursor 1010. Set LCD font to the largest 124, and set text color to black. Print word connecting, and then we run function check ID. This function is sending command 1900 into the radio and waiting for response. When it getting response with necessary ID, it stop and save the ID as variable radio ID. When we found radio ID, function while is stopping. In any case, if function will not find radio ID, in any case while will stop when radio ID will be 0FF 256. It will stop and show again on the yellow background that radio is not connected. So when we connected to the radio, we initialize graphic user interface. Let's see, it's a functions which in ILI9341H you can find the functions which you can use for work with the graphics. If you don't want to use graphic user interface, you can use just simple functions like draw pixel, draw line, draw circle, draw rectangle, fill rectangle. Okay, so when we finished when we found radio ID, we initialize graphic user interface GUI init. We run the function create window. I will show you it later. Then we set the port busy as 0, so we allow our program to send commands into the port. Then we start timer 6. This timer is sending CIV commands every 100 milliseconds, and we initialize our UART port for receiving DMA. It's mean DMA it's always listens the port, and when it receiving the data, it decode it and display on the screen. And we also start encoder timer. Now I did only one encoder, but totally there will be 4 encoder. For better performance, of course, the better is used two encoders with two double encoders. It's much better, but I don't have that ones. We are going to use only simple ones. So when we started encoder, we have variable CIV status. We set it as idle. I will show you later where is it. So it's our timer 6. Timer 6 sending 3 CIV commands, one by one. It's sending commands, then it's wait for response. CIV idle, we send in read frequency. CIV send CMD2 is we reading read. No, sorry, we reading CIV command 3, we reading read. Read S, it's read signal, it's CIV command 2. S meter. It's in CIV loop. So it's commands we are sending. Read frequency, read audio. And here we set the enumeration of CIV idle, CIV send command 1, wait command 1, send command 2, wait command 2, send command 3, and wait command 3. It's necessary to not mix receiving data with sending data. So we need to send command read frequency. Then before we send the next command, we need to wait, we receive the frequency and decode it. So this functions is very simple, just in our we setting only radio ID and sending command to your UART port. There is 4 functions, but we're using only 3. Read V is to read volume, but I decided to not put volume on a LCD, it's very small. So as you see, this function is we just change byte, the second byte into the radio ID, and sending to UART this function, this variable HUART1. It's command to send read F and length 6 bytes. So here in the file STM32F407+LCD in USART IRQ handler, we need to insert CIV, our CIV command starting, our CIV function. So when we start it, it's CIV process DMA. It's always listening the UART port. So we don't need to write any code for that. Just add this function into USART1 IRQ handler. Let's see this function, how it works. This function is located in CIV DMA. So it's CIV process DMA. So we just this function is just getting the packet of bytes from the port. And if we got more than 6 bytes in response, we run next function, CIV parse, which parsing CIV command is checking if the command received is Icom CIV command, and if it's CIV, it's take out the data. So we need to compare to check if it's CIV. We need to compare first 2 bytes if it's FE, FE. If both of them FE, FE, and last of the packet byte is FD, the command is CIV, so we need to work with it. But there is a small problem, because Icom in response always sending in front of command, it's sending echo, received command. So if you send in FE 74E003FD, in response will be 6 bytes the same, and then only real response. So we need to compare if it's echo or it's a response, because in response is E0 and radio ID is replaced. When we send in command radio ID is second byte, in response is third byte. So we need to check if it's echo second byte, we need to pass this packet. When we got the command, we need to take out the data. So we need CIV decode. I decided to make here switch case. If command is 03, we run decode frequency function. If command is 15, it's S meter. If command is 21, it's read. So we need to check which command we received. We're checking it by the first byte, and then for each command we decoding. We decoding the data and send it to LCD. Its frequency we convert to the string, to visible. Same with the read data, and for S meter we just need to get integer to make width of the picture on the progress bar. This line text, send text, hText global frag_str, it's sending to our window DLG file to update what's inside the window DLG. This one's hex data is images. Here is described our components. It's our window 320 to 240, button, text, image. For this meter we're using two images, external and internal. And when we send text to the LCD, it's our 0, 0, 0, 0, 0. It's our place to send. And hText global VM get dialog item MSG. So this line is to send the text to the LCD. Same with the read. And for the S meter, we're just using picture width.